QWQ came out, and I'm always excited about reasoning models. I love them. QVQ was a model that actually I ran it a lot for a long time. But I will say there was a little bit too much hype for me. Not to call these people out, because this is really what everybody's doing. They're just hyping up these models and stating whatever marketing material the company that made it put out. You see things like this where they say it compares to DeepSeek R1 671 billion parameter model. They do not want me to take DeepSeek R1 and put it head to head against this QWQ model. But this 32 billion parameter model is actually really good. My big complaint about it has been the amount of thinking it does. And I needed to figure out a way around that, which I'll get to in a second. And what led me down this path was this post by Bindi. She said, it is indeed the world's best open source model. She said they reran their test, and using the settings that the Qwen team recommended, it got an excellent score on LiveBench AI. So, how did I actually improve this model so it actually is usable for me locally? I started playing around with a bunch of different prompting configurations. To start with, if I just tell it to generate a game of Python, it takes 12 minutes and 51 seconds. I do not have time to wait 12 minutes and 51 seconds. And then the game was not functional. It is not functional. If I test this game, it is not functional. So not only did I use 12 minutes and 51 seconds, I got an incomplete or broken version of Tetris. So then I started thinking, how can I influence the time that it thinks? Because I don't care about its accuracy in a lot of cases. A lot of times it'll be halfway through its thought process and find the right answer, and then just go off into a tangent only to come back to its right answer. So how can I control that a little bit more? So my first test I did is like, can I actually make the code better by telling it to think longer? So in this one, I say think as long as possible. It is so imperative that you get the right result. So the exact prompt I did is think as long as possible to generate the best result. It's more important that the application is perfect rather than focusing on speed. And then I say generate a game of Tetris in Python. And it went to 19 minutes and 16 seconds. And it generated 16,949 tokens compared to 12,080 tokens. So I got it to generate a significant amount more just by changing the prompt. So then I was like, how quick could I get it by telling it to be urgent? So what do you think? How long do you think it would take if I tell it to be urgent about it? I thought 3 minutes, to be honest with you. I thought I could probably get a result in 3 minutes, and it starts to get a little bit more usable. But this blew me away. I ended up with 24.63 tokens per second, 1,764 tokens total. And this is about the same quality that I got when I did the one at normal time. It only thought for 23.27 seconds. Significantly different. And I found this to be very repeatable. So what I started doing is actually using this to generate like unit tests for me. I used this yesterday to generate a ton of unit tests. A lot of them I did in Open Web UI. I brought them into here to show you some of how this could work. And then I've changed my system prompt to just say your response is time critical. I do think it works slightly better if you add on a bit more to it, where I say get to an answer as quickly as possible. I think giving it this full sentence actually works well. Remove this generate in here. This is an error. I was testing your response is time critical, generate a game of Python, and then I copy and pasted that incorrectly. It didn't seem to impact the results, so I'm leaving the results as is. And then I started using it with reasonable amounts of token generation and speed to actually get API test planning. So I started thinking, this can actually be one of my models that I always am using. It's amazing because I'm going from waiting 15 minutes for something to now getting it in minutes. So just to show you what the think time was on this one, I actually put a lot of code in here because I gave it one of my API classes, and it ended up thinking for 1 minute and 11 seconds. I didn't run this against a non-time critical one, but I can promise you from past experience, it would be a lot longer. But then I was like, what about calculus? What about math problems? So I told it, think as long as possible to get the best result. And actually, I took the exact same one about the application being perfect rather than focusing on speed. Then I said, find the derivative of this function, which it ultimately came out with the correct answer, which is 12x cubed minus 4x plus 5. And it did that with thinking for 2 minutes and 6 seconds, by thinking as long as it needed to do. So I was like, okay, what is it if I tell it to be time critical? 24.88 seconds, the same answer. So we have saved we went from 2 minutes and 6 seconds, 3,132 tokens, to 815 tokens in 24.88 seconds. Note, I don't have the time calculated for all of them, but you can kind of correlate that with the tokens per second and the total tokens. But most of the time is spent in the thinking. So this model, creating these prompts, has actually changed the way I want to use this model. And I've been working on this in Roo Code. So for example, I created this system prompt specifically for QWQ called time sensitive, and I've added that as part of my prompt. And I've had it generate code for me, and it did the tools properly. So let me just show you what this looks like when I run it. So this is an A-star pathfinding algorithm. It's got some errors in it, right? So if I click over here to the right, it's actually going to put it down here because everything's kind of inverted, I believe. That's my theory on it. So I'm just going to put a line across. This is going to be the A-star pathfinding algorithm. Let's see if it works. It's going around. It perfectly found the path. That represented it really well. It did this in one shot. Now, when I did try to tell it the error with the clicking being off, it finds the problem. It tells me what it is here, but it gets in this infinite loop where it keeps wanting to read the file. So I need to figure that out. I haven't quite cracked that part of the problem yet, but this is so much better than what I was getting before, which was waiting forever for the code to even get in there, and it's sometimes not even reading the tool. Now I can actually make this usable to a certain degree. It's not perfect in Roo Code, so this is getting there. And it's all by overriding that system prompt like I've covered in other videos that I've done. So then this led me down another path, which is how much does this impact things like Grok? So Grok basically has this think mode. I'm paying for Grok currently. My theory was if this impacts QWQ, I have a feeling it should impact Grok. Now the problem that we have here is the hardware we're running on is variable. We don't know how much compute is being given to each one of these queries. So all we really have to go off of is the amount of time. We actually don't even get a token count in here, which is one of the things that I would love to have an API for, so we could actually do more analysis. So bear with me about this inconsistent result, but it still, I think, should be you should be able to relatively correlate results together. So I told it its response is time critical, get to an answer as quickly as possible. Now, one thing I'll say is this one thought for well more than QWQ did based on that time critical sentiment. And I'm running on hardware that is super small. This model's giant, though. It's going to be more compute intensive, and it's probably going to have a better version of this game in its first go. I did not test this code, by the way. So I actually thought this was going to come in at 10 seconds, 15 seconds, stuff like that. But it didn't. It came in at 104. So then I say, regular, what is it? And it thought for 102 seconds. And just to be very clear, I did this test about 3 times for each one of these, and the results are relatively consistent, except for one that's kind of an anomaly that I'll talk about here in a second. And then I said, think as long as possible. And it ended up shorter. And I didn't understand, like, how could this end up being less? So my theory now is that Grok just does not pay attention to that. It has its own override for how much thinking it should do. Except I got this one outlier where it actually thought for a long time, 162 seconds. This was, of my 3 tests I did one that was 92, one that was a little over 100, and one that's 162. So this makes me think that most likely Grok is ignoring it and not paying attention to it. But until we get a token count, we really can't know that 100%. So now what we're going to do is we're going to do this live because I want to see if Claude 3.7 Sonnet actually is impacted for this. Because you remember, this is kind of like a hybrid model where we should be able to influence how long it thinks. And this one also does have this like thinking timer that you can see here. So right now it's going at, 2, 3 seconds. It thought for 3 seconds. So we're going to go ahead and just assume, it's generating code now. It did very little thinking. Very few tokens actually got put in there. So now for the next test, we're going to use Claude 3.7 Sonnet and extended thinking, but we're going to tell it to think as long as possible. And we're going to use that prompt that I had before, and we're going to go ahead and send this off. And do we get more thinking here? And this is going to be interesting to me because this hybrid model approach, in theory, should pay attention to my prompt here. So check this out. We're at 20 seconds in. It's still thinking. Now compare that to 3 seconds of thinking here. So think about what we can do with our prompts over in Roo Code using Claude 3.7 Sonnet just by telling it to think more. Now, the one thing I need to actually do more testing on is, does this actually produce better code or better architecture or better answers to questions? That I need to test a little bit more. And I plan to be doing that over the next few days. But I wanted to share this with everyone because some of you may know this already and I'm just catching up and maybe I'm behind. But to me, this is actually a big unlock because utilizing models like QWQ and telling it the urgency of the problem or telling it to think harder is actually really, really powerful because now we can start moving these reasoning models into our workflows and not have it take 15 minutes to generate an entire like 50 lines of code. It's so much better. Look at this. We're actually at 1 minute and 21 now of thinking. All right, so now it's generating the code here. 2 minutes and 26 seconds of thinking. I would love to know the token count here. So one of the things I've complained a lot about with Claude 3.7 thinking is the amount of tokens it generates, where it gets kind of expensive. So I'm actually going to attempt creating some override prompts and basically tell it to think as little as possible or be very urgent in its reply or something like that. I'm going to try to figure out which prompt it pays attention to the most. But anyway, I really did just want to share this with you guys. I'd love to know how you're using QWQ, if you're actually using that. And hopefully these prompts help you. If you already knew about it, let me know if you've got any other secrets that I should learn about. This is something I kind of discovered myself just kind of thinking about it. But I'm sure if there are people out there that have come up with like some prompts that are making these models work better. And I think that's about it. Hopefully this was helpful. If it was, please let me know in the comments below and give me a like and subscribe if you wouldn't mind. That would help me so much with the algorithm. Until next time, everyone. Peace out.